I upload the recording to, not this recording from previous year. I upload it to the YouTube. Okay. So, and this short missing part, you can watch it online on YouTube. Also, I can upload the lecture of the previous section. It's have the recording also. No problem, inshallah. Next time, if I forget, please remind me early, yes? It's first time for me to forget this. Actually, you know why I don't feel stable. Today, I'm teaching from my office room. And when I came to the office room, because it's closed for around 1 week, I feel the temperature very hot inside, like, like I'm sitting in the sauna, yes? So I cannot breathe even here inside the room. Okay, anyway, let's continue. Thank you for uh, reminding me. Okay, so until now, we just mentioned few things. The most important now here, we have two operators. You have to know these two operators and know how to differentiate between these two operators, which is AND operator, star operator. You must know these two operators and understand them and know the difference. If you did not understand after we finish, ask, because you must understand them. Okay, what AND operator? We take it, if you remember last year, last semester, when we take a scanf, we use this AND operator. It's give you address of the variable. We said any variable in the memory. For example, variable num here in this example, it's have address. Let's say, for example, 1000 address. So if we said at num, for example, what this mean? This mean address of num. So it give you 1000. This semester I'm very busy. Always I said I will buy a new writing tablet to write, and I forget. I keep forget. Hopefully today, after finish this lecture, I will order it directly. Okay. This is the address. So address give me address of a specific variable. A star operator give me value. So at give me address. A star give me value stored at the specific address. So value stored at the specific address. So if this one and num give me address of num, if we said outside it star, means give me value inside this address. So it will give me, if num equal, for example, 10, so it will give me this value inside num. So star means value stored in a specific address. Let's see in this example. In this example, we create integer num. We give it 10. Okay, we give it 10. Then we print num, print variable, like any variable. So it will print 10. Until now, we did not use the two operators and and the star. So print num, it will print 10. Print address of num. So imagine in the memory, we have this address 642044, like in this output. So address of num means the address of this variable. So this will print this address 642044. Okay. Print star means value. Yes, value. Value inside this address. What's this address? This address of num. So value inside it, it's value of num. So it will print 10. So star means value. Value is stored in this address or stored in this address. What's this address? Address of num. So address of num, what's the value inside it? It's 10, which is the value of num. So this printing and this printing same. If we print num directly means the value inside num. If we print star and num means and num give me address of num. The star means the value inside this address, which is the value of num. Why all this turning? It's only to know the difference between these two operators. It's not to know the difference is very important because we will use it too much with the pointers. So these two operators, it's related to the pointers. Okay, so now let's take example with the pointer. First of all, we create variable num and we give it 10. So in the memory, if we imagine that it's working like this, in the memory we have the variable name, which is num. We have value, which is 10 here. And of course, any variable in the memory have address. Imagine that its address 8280. Now we create a pointer. How we know that we create a pointer? Okay, data type, star, and name. So this is the name of the pointer. This means it's a pointer. This data type means this pointer point to integer variable. This statement in the memory like what? Like this. It's a variable, its name ptr. Its value is still we don't know. Until here, we still don't know. So it's empty, null. And of course, because it's variable, so it's have address in the memory. For example, 8272. Okay. Now we want to make this pointer. We want to make this pointer ptr. We want to make it point here, point to num. To make it point to num, we have to give it address of num. So we said ptr, it's equal address of num. What's this mean? Get address of num. This address of num, store it inside ptr. So we stored it inside ptr. When we stored it inside ptr, this address of num here, 8280. This means this pointer ptr point to num, point to this variable. So to make this pointer ptr point to num, we give it address of num. Now let's see some printing here. Print num. What's this mean? Value of num, which is 10. Print BTR. What's this mean? Value of BTR, which is here. It's have 8280, which is address of num. So it will print 8280. Okay, print at BTR. What's the meaning of at? Address. Address of what? Address of BTR, which is here. Address of BTR as variable. So this will print 8272. Okay, let's take a look here. Print star BTR. Star means value. Okay, which value? Value of this address. What's this address? It's address of num. So this means value of the value pointed by this pointer by num. So it's value of num. Why value of num? Because BTR has the address of num. So value pointed by this address, this value. So it will print 10. Okay. So star BTR means it's same, it's equivalent to the name of the variable directly. So if you use star BTR, you can print num. If you use num, you can print num. So star and the name of the pointer means the value pointed by this pointer, which is here the value of num. At pointer or and pointer means the address. So and means address of the pointer in the memory. Okay, let's take another example. Actually, if we said that value or star BTR, if we use it, it's same like we use the original variable, which is num in this example. In another example, maybe another variable. So using star BTR, we can set it's equal 20. What's this mean? This mean value of num will be changed to 20. So we can reach and update and change the value of the variable using star the name of the pointer, using the pointer itself. Like in this example, we have variable num, we have pointer at the beginning, point to null means point to nowhere. Then we said that BTR equal and num means we make BTR take the address of num. This means BTR point to num. Now print num means it will print 10 because we give it value 10. Star BTR equal 20 means it changed the value of num to 20. How do we know? Star means value. BTR means the pointer for num. So value pointed by the pointer means value of num. So we change value of num to become 20. Now if we print num, this means it will print 20. If we print the star BTR, okay, what is star BTR? It's num itself. So it will print also 20. Let's try it. Okay. Update variable. So we have num, then we have pointer for it, then we print it, we update num using the pointer. So it's different if you did not put here star. This means you make num point to somewhere in the memory which is 20. And we don't know address in the memory 20 what it have. Yes? So, but when we said star before the pointer means value pointed by the pointer, which is same num. So here it's like we said that num equal 20. Now we print num and we print num here, same, because star BTR means num also. Let me just close this one. It's already so run, as you can see here. Before update num, it's print 10. After we change it here, so if we print num, it's give us 20. If we print num using VTR, it also give us 20. Okay, let me just see something. What's the meaning of a print PTR itself? The meaning of a print PTR alone means the address is stored inside PTR. So it gives us what? Address. Address of what? Address of num. So if you said like this, because as you can see here, we said PTR, it's equal address of num. So if we print here address of num, it's same like print PTR, because PTR contains the address of num. As you can see here, this statement print PTR, this statement address of num. Okay. So if we said here star means value pointed by PTR, which is num. If we said here star, this means value pointed by the address of num, which is the value of num itself. So this statement and this statement also give me same, which is the value of num. There's one missing here. Okay. So as you can see here, this statement print num directly. This statement print num through BTR. So value pointed by BTR, which is num. This statement print value at the address of num, which is the value of num, which is 20. So this way of using the address operator and the star operator, which is the value operator. Okay, size of the pointers. Actually, you will see later the importance of the pointer, because until now you will say, okay, why to use the pointer? I can use num directly, and I don't care about the address in the memory. Actually, no one will use the address in the memory, but the pointers, it's important in programming in many cases. For example, last semester we take something called call the function by reference and call the function by value, or give the argument by reference or give the argument by value. We show that when we pass variable for a function, we actually pass its value. So if you change the value inside the function, it will not affect the original variable. But the other way, it's using the pointer. We can pass the address of the variable. When you pass the address from the memory, this means pass by reference. You can, when you change the value of the variable inside the new function, it will affect the original value. In some cases, we need to keep the original value, so we have to use the pointers. Also, some important data structure like linked list and so on, it's use also the pointers. So it's actually very usable in programming. However, one of the most important programming language, which is Java, it's not directly using the pointer. You cannot use the pointers in Java, but it have some way else. It gives you some way else to have some data structure like linked lists and so on, because it's need pointers, but Java give you some other options. Okay. Anyway, it's not our job now. We know that we have to know that pointer is one of the important subject in programming here. So we said that pointers store address of other variables, yes? And address of the variable, it's integer value. And we said that this value, it's different from one compiler to one compiler. For example, integer value in Poland C compiler is one type of the compiler. Actually, it's Asian type. I mean, old type of the compiler. It's take 2 bytes for the integer value. Other compiler like Visual C++ and some current compiler use 4 bytes for the integer value. Some compiler give same size for the pointer, which is 4 bytes. Some other compiler give different size for the pointer. So each variable have size, yes? Integer have 4 bytes in most compilers. Float have 4 bytes. Double have 8 bytes in most compilers, and character have 1 byte, and so on. Also, pointer have specific size depend on the compiler. For example, in my computer, here in my compiler, it gives size 8 bytes for the pointer. So actually, because of this difference from one compiler to another compiler, and from also one computer to another computer, it's depend on the hierarchy or the structure of the computer, we need to check the size of the variables and check the size of the pointers. We will see later that we need to know the size of the pointer. So to know the size of the pointer or any variable, we can use the function size of. Simply size of, and inside it we give the name of the pointer or the name of the variable. It will give us how many bytes the size of that variable or that pointer. Okay, so let's see in this example here, it's related to this example. Okay, we have here character data type ch, integer data type I, float data type f, decimal data type or double, sorry, data type d. Okay, we can imagine it in the memory. Character have 1 byte, integer have 2 bytes. In my compiler, by the way, integer have 4 bytes. I think most of you will have 4 bytes for the integer. Float 4 bytes. Most compiler is 4 bytes. Double in my compiler 8. Some compiler take it as 16. Some compilers as 8 bytes. But you will see whatever the data type of the pointer. Okay, for example, ch is it's a character pointer because it's point to a character variable. IPTR, it's integer pointer because it's point to I, which is integer variable. FPTR, it's a float pointer because it's point to F, which is a float variable. DBTR, it's a double variable because it's point to D, which is a double variable. However, each one point to different data type, but all the pointers have the same size in the same compiler. So in my computer, doesn't matter the pointer point to which value, it will take size of 8 in my computer. Here in this example, it's take size of 2. So this one, if it's address 8,000, next one 8,002, next one 8,004, next one 8,006. They have same size. Doesn't matter the pointer point to which type of variable, they have same size because all of them have address, which is same data type. The address here, it's integer value. Okay. Where's here? Okay. Let's take this example. I will take it one by one here. We will finish on time, inshallah, don't worry. Yes, we start little bit late, 5 minutes, but we will finish on time, inshallah. Okay, so we have here, let's take it directly on the compiler. So as you can see here, we have 4 variable, character ch and have initial value a, integer I have initial value 10, integer f have initial value 12.34, double here float value, here double value d, which variable d, which have this value. Now we create what? Pointer chbtr, and we give it address of ch, means it's point to ch. We create integer pointer IPTR, and we give it the value of I. This means it's point to I. We create a float pointer FPTR. So it's a pointer, it's point to F. We give it address of F, so it's point to F. Look here, character variable have character pointer. Integer variable have integer pointer. Float variable have float pointer. Double variable have double pointer. Okay, so here we print star ch pointer. What's this mean? Star means value. Pointer, it's point to the address of ch. So value pointed by this pointer means the value of the variable pointed by the pointer. So printing star chptr, it's same like printing ch. Let's take it here and see the output. So if we print star chptr, this means print value pointed by this pointer, which is character. So that's why we print character. See the printing here, it's a print A. So we can also print ch directly, yes? Print character ch means print A. So it gives us same value. So print ch or a print star ch ptr. So print the variable through the pointer. This is the meaning of star chptr. Okay. What if we said print chptr without a star? This means we print the pointer itself. What's the pointer? The pointer have the address of ch. Try to print it. It will not print anything. Why? Because we did not change the data type. Actually, pointer value, it's integer. So you need to change this to become integer. Now it's a print the value. Which value? Its address is stored in chptr. What address? Address of ch. So print chptr means address of ch. Okay. So print the pointer without a star means print the address of ch. You can try it. Let's print star ch. Look to the value, it's same value of the pointer. Why? Because we said the pointer equal the address. And you have to focus here. If you create like this, first we define the pointer. Now, what we have to say to make this pointer point to ch, we have to set ch ptr and before it start, no. To make the pointer point to it, we have to set that the value of this variable, which is the pointer, equals the address. Now it's correct. Value of variable. What's the problem here? It's not correct the name. Yes. Okay, now it's correct. Okay, as you can see it here. But if you said star ptr equal, what's this mean? I will show you what inside it. What's this mean? This means value pointed by ptr equals the address of CH. What's the value pointed by SHPTR? There is no value. Yes, it's null. So if you see, it's stuck. Yes, because it's like what? Like you said, we have pointer. This pointer point to nowhere, and then you said that this nowhere value it's equal to this address. So nowhere, the compiler start to check where is this nowhere. I cannot find it. So to make pointer point to specific address of variable, don't put a star. But why here we have star? This star, it's not related to give the value. It's related to define the pointer. So if in one statement you use this star because it's defines a variable, but we already defined the variable with the star here, define shptr. So next time, if you will use shptr to point to a specific variable, you don't need to put the star here again. Star again means value pointed by this variable. Okay. Let me just return the code as what it was. Okay, so now continue. Then when we print the star, S star means value, character PTR means pointer of CH. So value pointed by this pointer means a print CH, which is A. Same issue here. We print what? We print CH using PTR. We print I using PTR. We print F using its pointer. We print D using its pointer. So we print the values here. You can use the name of the variables directly. Also, you will get the values. Okay, continue. Look here. We print here in this statement, we print address of CH. So address in the memory of CH. Then we print size of CH. What's the meaning of size of CH? How many bytes it will take in the memory. So CH's character, it will take 1 byte. So this one will print 1. I, it's integer. Its size in my computer 4. If it's a float, its size in my computer 4 also. D, which is double, its size in my computer 8. So 1, 4, 4, 8, it will print. Okay, so this CH address, this I address, this F address, this D address, and this the size of character, which is 1 in my computer, size of integer, which is 4, size of the float, which is 4, size of the double, which is 8. Now, let's see the size of the pointer. Okay, size of the pointer, character pointer, is it different than size of integer pointer, size of float pointer, size of double pointer? Size of the pointer, it's point to character or integer or float or double. Is it different? I mentioned it. No, it's not different because the value inside any pointer, it's same, it's address. So it's integer value. So they have same size. This one, this one, this one, this one will give you same size because the pointer, it's pointer. It's have the same size. Doesn't matter the pointer here, what its data type. This data type is related to for which value it would point. But what address inside it? It's integer value. So in my computer, it's take any pointer take 8 bytes. So as you can see, size of character BTR 8, IBTR 8, FBTR 8, DBTR 8. All the pointers have same size in the same compiler.
Sir, I have a question.
Yes.
Shouldn't integers be 2 byte?
I said it's depend on the computer. In my computer, integer 4 actually. Here,
Yeah, I saw it with the period.
it's size 4 in my computer. Size of I, it's 4. In other computer, maybe 2. I don't know. And size of integer, it's different than size of the pointer. Pointer have integer value, but its size not related to the integer size, okay? In my computer, the size of the pointer, it's 8 bytes. Size of integer, it's 4 bytes. Maybe in your computer, it will be 2, depending on the compiler and depend on also the architecture of the computer, okay?
Okay, thank you.
Welcome. Okay, so let's continue. Pointer chain. So pointer could point to another pointer because, as we said, pointer is a variable that point to another variable. And we said if we imagine in the memory that we have variable num. For example, its address 1000. We could have pointer ptr point to num. So just be sure that you muted your mic, okay? Do not disturb your friends here and disturb us. Okay, so imagine that we said that integer pointer ptr equal address of num. So this means we make ptr point to num. How to make it point to num? We take address of num, which is in this example 1000, so we store 1000 inside it. Okay, we could have another pointer in the memory, ptr2, and we want ptr2 to point here to ptr. Actually, ptr2, we have to define it as a pointer, yes, ptr2 star. This means pointer ptr2. And then before it, we have to mention for which data type it will point. Okay, for which data type? For integer pointer. So for integer, if you said integer alone, means for integer variable. But for integer pointer, for integer star. So this means to make pointer point to another pointer, it should have 2 stars before it. This means pointer ptr2, it's a pointer for a pointer. Then we can give it address of BTR. So this means BTR 2.2 BTR. Imagine that BTR have address 2000. So this means we sort here 2000. We could have another pointer. Yes, you could have BTR. It's a chain. You can have as much as you want. You can have BTR3, for example. Point to BTR2. Okay. So let me write it here. BTR3. It's a pointer. This pointer need data type. What's the data type? If it's point to BTR2, BTR2 type, it's star star integer. So integer star star. So as you can see here, how many stars? We have 3. Why 3? Because we have 3 pointer chain. BTR2 point to BTR, BTR3 point to BTR2, BTR2 point to BTR, BTR point to num. So we have 3 pointers. That's why we have 3 stars. If the pointers related, we could have like this example. We have here 1, 2, 3, 4 pointers. Okay, each one only one pointer because it's point to normal variable. But when you have like a chain, pointer, point to pointer, and this pointer point to pointer. So for each let's say for each part of this chain, you need a star. Okay. Like in this example, we have integer num. So num, it's have address and it's have value. Now we said integer star BTR, we give it address of num. So BTR, it's a variable in the memory, which is pointer variable, and we give it address of what? Address of num. So this means it's point to num. Now we said we have pointer of pointer. So we could have pointer of pointer. We could have pointer of pointer of pointer. Pointer of pointer of pointer of pointer of pointer. Depend on of how many pointer we have, how you will have how many stars. So it's pointer of pointer means 2 stars. And we give it address of BTR. Address of BTR here. So address of BTR means it's point to BTR. Okay. We need something like this. Yes. For example, if we use multiple dimensional array with pointers, so we need to use, because you know we have rows and columns, and each one will have pointers, so we could have pointer of pointers and so on. We will take examples maybe next week or after 2 weeks for this. Okay, the question here, we can reach num using BTR2? Yes, we can reach it. Because from num BTR2 you can reach BTR, and from BTR we can reach num. So you can reach num actually through BTR2. Let's take example. In this example, as you can see here, in this example, we have integer num as 10. Okay, integer num have 10 and let's have address. Star BTR equal null at the beginning, but after that we make it point to num. So we give address of num for BTR. This means BTR point to num. Then we create pointer of pointer BTR2. So we give it address of BTR. This means BTR2 point to BTR. Okay, now print num. Print num, it's a variable, print it will print 10. Okay, print star BTR. What's the meaning of star BTR? Value pointed by BTR. Which value pointed by BTR? Num. So star BTR means num, value of num. So it will print 10. Okay, look to this one. Star BTR2. BTR2 star value pointed by BTR2, which is this address, which is same address of num. So this give me address of num. So inside one. Then outside the star it said value pointed by this address. What's the value pointed by this address? It's value of num. So I reach num through the second pointer. How to reach it? A star inside the parentheses, then another star. So this equivalent to num also. And give you 10 for the printing. Okay, we can change the value of num using pointer of the pointer. Yes, value of num means star BTR. So this BTR2, of course. This reach value of num. Another way to reach value of num is star BTR. Another way to reach value of num itself. So this one, same statement. Let me just correct this one here. BTR2. Okay. This is statement, same. So if we said the star BTR2 equal 20, means it changed BTR2 through this pointer, num through this pointer to become 20. Star BTR equal 20 means it changed num using BTR to 20. Num equal 20. This means directly change the variable to 20. So in this example, we change the value of num because we reached num using BTR2. So we need 1 star, 2 star, we reach num. If 1 star alone, this means BTR become 20 because value of BTR2 means value pointed by BTR2, which is BTR. But when we said here, another star outside, this value pointed by BTR, which is here, then value pointed by this address, which is here. So it's equal num. So this changed num to 20. Now, if you print num, it's give you 20. If you print num using BTR, so value pointed by BTR, it will give you 20. If you print value pointed by BTR2, then value pointed by this pointer. So we reach also num using BTR2, so it will print 20 because we already changed it here to 20. Any question? Okay, so let's continue. Now we have important subjects that usually come in the exam, which is arithmetic or pointer arithmetic. Pointer arithmetic, actually, we have increment operation, decrement, and we have addition and subtraction or minus. Increment means increase by 1, decrement decrease by 1. Addition, we could add any value. Subtraction means we could minus any value. Minus from where and add for where. It's depend on you will minus or add for whom. Maybe for the address of the pointer, maybe for the value pointed by the pointer. So when we said increment the pointer by 1, means make the pointer point to the second block or the next block. And we said the block, it's have different size, depend on the data type and depend on the compiler. So, for example, let's take this example. We have integer variable I. So we have in the memory integer variable I. And we have integer pointer IPTR. Okay, IPTR. Then we said IPTR equals the address of I. So we make IPTR point to I. Imagine that I have address 1000. So we said IPTR value is the address of address and means address of I. So it have 1000. So we imagine that IPTR point to I. Now we said IPTR means the value inside IPTR, this value, which is 1000, plus equal to means add 2. It's become 1002? No. Add 2 means 2 blocks. Okay, what's the size of the block? Depend on the data type, it's integer, okay, and depend on the compiler. This compiler, how much take for the integer? For example, if the compiler take 2 bytes for the integer, this means 2 blocks multiplied by 2 bytes, sorry, multiplied by 2 bytes, which give us 4. So add 4, add 2 means add 4 bytes because 2 blocks here. Add 4 bytes to IPTR. So IPTR it's 1000. Add 2 blocks means it's become 1004. So this means IPTR now do not point to I, it's point to somewhere else in the memory, which is have address 1004. So we change the address, we change IPTR, it's point to another place now. Let's take examples here. Focus to these examples. Because it's different when we use it with the star, it's different when we use it with the address operator, It's different if we use the star outside the parentheses or inside the parentheses. It's make difference because parentheses have highest priority, yes? So it will make a big difference here. In this example, we assume that the compiler use 4 bytes to store the integer value. If we ask you a question, we have to mention how many bytes we will use for the integer value, especially the integer value. Because the float, usually we take it as 4 directly, double we take it as 8, a character we take it as 1. The difference here in the integer. So if we speak about integer, it's better to mention how many bytes the integer will be. So in this example, we take the integer as 4 bytes. Okay, we have integer I with value 10. So imagine that in the memory, we have integer I and its address as 1000, just as example, this 1000. Okay, 1000 and its value 10. Now we have also IPTR as a pointer. Then we said that IPTR equal address of I. So it's have address of I, which is in this example 1000. Okay. Now let's take each operation here. Okay, this is common with all operation, but each operation we make it separately. Okay. Star IPTR. This inside parentheses, so have the highest priority. What's the meaning of star IPTR? Star means value pointed by IPTR, which is I. So this one equivalent to I. A plus plus means I plus plus. So star BTR means I. A plus plus means I plus plus. So increase I by 1. Value of I 10, increase it by 1, it's become 11. So this one actually is star IPTR inside parentheses plus plus means it's equivalent to this one I, this one plus plus, so it's equivalent to I plus plus. Okay, let's take another operation. IPTR plus plus. What's the meaning of IPTR? IPTR means the value inside IPTR, which is 1000. A plus plus means increase it by 1 block. This means increase IPTR by 1. By 1 what? 1 block. What's the size of the block? It's 4 bytes, as I give you here. Assume the compiler use 4 bytes to store integer. So the block size is 4 bytes. So this means the value inside IPTR will be increased by 1 block, which is 4. So it's become 1004. What's the meaning of 1004? This means it's point to somewhere in the memory else, not pointing now to I, it's point to a place on the memory with address 1004. Okay, let's take next statement. Imagine that we sell at the original one. Okay. I said each statement consider it as separate, just to take examples. So we still have this one like this, and this point here to I. Okay, so we have like this. Now we want to say, to make star IBTR plus equal to. Star IBTR, what's this mean? It's mean I. Star IBTR means I. Plus 2 means increase I by 2. So it's equivalent to I plus equal 2. If IBTR cell point to I. Star IBTR plus 2 means star IBTR, it's I. Plus 2 means increase it by 2. So it's become 12. If it was 10, it's become 12. Okay. Next statement. Same idea. Star IBTR means I. Yes. Equal 7 means it's equivalent to I equal 7. So we change I and I become 7. Okay. Let's take this one. Star, but inside parentheses here we have IBTR plus 4. Plus 2, sorry. What's this mean? Okay. IBTR alone. It's the value of IBTR, which is 1000. Because we have high priority for the parentheses. The star, it's outside the parentheses now. Or parentheses. It's outside it. So we take inside the parentheses first. IBTR, which is have value 10,000, plus 2. 2 what? 2 blocks. 2 blocks means 2 multiplied by, what's the block? 4 bytes, we said here. So multiply by 4. So this one equal to 1008. So inside this 1008, and here star. So its value 1008 means somewhere here. And we said star. What's the meaning of a star? Star means value. Value is stored in this address. So this one give me address 1008. Then we said value inside this address, it's equal 5. So we stored 5 here at the address 1008. Okay, so this means assign value, star means value at this address. How to calculate this address? Value inside IPTR, which is 1000 plus 2 blocks. 2 blocks means 8 bytes. So value inside the address 1008. So that's all for today. If you have any question. Any question? We just finished on time, yes? Okay, if you don't have any question, You will take more examples, inshallah, in the on Wednesday on the lab. Also, we will take more issues related to the pointer next lecture, inshallah, and you will take more examples. See you, inshallah, on Wednesday or next week. I will stop the record. You can leave the meeting. We finished today.